Hi, this is Dr. Thompson from Taylor University, and we're going to do another integration by parts example. This one's a little counterintuitive, which is why we're covering it here. So on the bottom here, you have the formula for integration by parts that we're going to use, that we talked about in the last video. Up here we have our example, which is the integral of x times ln of x dx. And over here on the side, this is a list for how we're going to choose u in the formula. So from the top down, we're going to start with inverse would be our first choice, and by that I mean inverse trig things like arctangent or arcsine, then logarithms, then algebraic things like x squared or x cubed or x. And the reason why it's called algebraic might be unclear to you, but just think of what kind of functions did you talk about in algebra class in high school. And then trigonometric, and then on the bottom, exponential does not mean x squared or x cubed, it means e to the x, the exponential function, or 3 to the x, or things like that. The reason they're in this order is they're in this order by how hard they are to integrate. So the top ones are very hard to integrate. You can do them with integration by parts, but they're kind of messy. So when you look at this one, if we follow that rule of thumb, we're actually going to make u ln of x, even though in a previous example we saw that if you picked x to be u, it would go away and become 1. However, that would mean we'd have to integrate ln of x, and we don't want to do that. That's too difficult. So let's go ahead to the next slide where we make our choices. So here we have u is ln of x across the top here, and dv is the rest, x dx. And so that means when we differentiate ln of x, it becomes 1 over x dx, right? That's its derivative, and that's helpful because that means we're going to be dealing with rational functions altogether, and we can probably integrate those. And then v becomes x squared over 2. So on the next slide, we will go ahead and change this integrand using integration by parts. So let's go ahead and do that. So here we've changed it right here in the blue. U times v is x squared over 2 times ln of x. And then the integrand becomes x squared over 2 times 1 over x dx. And that looks a little messy right here, but we can simplify that, right? We can cross out an x on the top and bottom. So let's do that on the next slide. We don't need this, so we'll move that out of the way. And here on the next slide, you can see that this integrand here simplifies to 1/2 x dx. And now that is something we can easily do the antiderivative of. The x becomes x squared over 2. So you have this part that you don't integrate, you keep that. And then this other part we can differentiate, that we can integrate, and we get 1/4 x squared plus c. So that completes this example and shows that, hey, this did work out. Even though when you integrated x, you made it a little bit messier, it was more important that when you differentiate ln of x, it all becomes rational functions that you can simplify. So in the next slide, let's talk about what this would look like on your actual homework. So here's an example of what that work might look like. You start with the original problem, you make your choices for u and dv, and work that out. This is the new version of the original integral. You can cancel an x, and then you have this problem, which is pretty easy to work out. The whole point is to make an antiderivative here that's easy to do, and then you get your final answer here. All right, that's it.